In today's video, we are going to be introducing scientific notation. And what is scientific notation? It is basically a way of writing a really, really big number or a really small number. And scientists use this if they have to calculate distances, like really far distances. For example, trying to calculate the number of miles from Earth to Mars, right? That's going to be a really big number. So sometimes scientists use scientific notation to condense that number, make it look nicer. So the problem I have right here is a number in scientific notation. All right. That's broken up into three parts. The first part right here is the number out in front. There is always going to be only one digit before the decimal. Okay, it doesn't always have to be one. This could be also a 4, right? This could be just one digit before the decimal. And it's always going to be multiplied by a power of 10, meaning that it's going to have 10 times some sort of exponent. So there are three components to scientific notation. We have the number out in front times a power of 10. So let's take a look at some numbers and see how you convert them to scientific notation. All right, so number 1 here. So what I do first is I identify where is the decimal. And whenever there's no decimal, it's always at the end. Then I count the number of hops, the number of decimal spots it moves to get to right after the first non-zero digit. So the first non-zero digit, if I read this number from left to right, I'm reading this from left to right, the first non-zero digit's right here. So I'm going to put a little caret symbol right there. That's where I'm going to move my decimal spot to. So my number out in front is actually going to be 6.24. Then I'm going to see how many spots do I move the decimal to get to that point, that caret, right? So I'm going to move it over 1, 2, 3 spots. So I call them little bunny hops. Like you're moving the bunny to the caret. You're moving the bunny to the caret 3 hops to the left. So it's going to be times 10 to the third. So whenever you have a positive exponent, you're going to have a really big number, okay? Let's look at number 3. 8, 0. All right. I want to move reading the number from left to right. The first non-zero digit is 8. So I put my caret after the 8. So I'm moving this now 1, 2, 6 spots to the left. So it's 8.001. Always going to be times 10 to the 6 power, since it's hopping 6 times. All right, let's look at number 5. You're reading this from left to right. My caret goes after the 3, the first non-zero digit, right? So I go, now this one has commas. I'm just going to use those. It hops 3, 6, 7, 8 spots. So it's 3.09 times 10 to the 8th. So again, like I said before, when we have a positive exponent, it's going to be a really big number. What about really small numbers, 0.007? So the first non-zero digit from left to right is right here, the 7. So I'm going to put a little caret after that. Then I'm going to see how many spots it moves. 1, 2, 3. So it's going to be 7.0, or just you could write just 7 times 10. Since you're going the other direction now, so a really small number is going to be negative 3. Over here, the caret goes after the 6, right? Left to right, the first non-zero digit is 6, and it moves 1, 2, 3, 4, 5 spots. So it's 6.5 times 10 to the negative 5th. Okay? So you get the hang of things, right? So if it's a really small number, it's going to be negative. So if you're moving your decimal spot to the right, your exponent is going to be negative. If you're moving your decimal to the left, like we did over here, it's going to be positive. all right, and a really big number. So that's how you write numbers in scientific notation. Work through these problems, and good luck. Thank you for watching.